And it's our great pleasure to have Jonathan Stray here from the US. He's a scholar at the Columbia Journalism School. He's a computational journalist, and he teaches the dual master's degree in computer science and journalism and leads the development of a tool called a Workbench, an integrated tool for data journalism without coding. And we are very happy to have him here, and he will talk about an issue which we are all very much concerned about, at least from the organizers, and that is the relationship between data journalism and the scientific method or methods. So the relationship between how far should and could journalists go in using scientific methods to enlighten the public discourse. Jonathan, we're happy to have you here, and it's your turn.
Thank you. It's really an honor to be invited to speak here to such a group of scholars. So I hope I say something interesting. My talk today, first of all, I apologize. It's not in German, but we're gonna have to go with English. My talk today is on the relationship between journalism and science, specifically data journalism and science. Because data journalism tends to be the subfield of journalism that looks most like science or uses most scientific ideas. So what's the relationship? There you go. That's my talk. That's my advice. Journalists should use scientific method. You'll notice there's an asterisk. Basically, all of my talk is the content of that asterisk. So I'm going to produce a lot of sort of criticism of the idea of scientific method in journalism. But I want to remember that it's all under this asterisk, that I think it's basically a good idea for journalists to steal methodology and ideas from science. What I'm going to talk about is why that doesn't quite work and the sorts of adjustments that we're going to have to make to use these methods successfully in the context of journalism. The idea of journalism as a scientific process is actually quite old. Here is Joseph Pulitzer talking about it in 1904. You probably remember the name. He founded Columbia Journalism School and the prize which bears his name. This is a fascinating booklet that's available online. It's a 60-page essay on why he's starting this journalism school and what a journalism school should teach. And I discovered a few years ago that he has this section on the use of statistics. And already in 1904, people like Pulitzer were thinking that there was a place for something scientific in journalism. So in this case, he's talking about the analysis of statistics has become a well-developed science. But I think perhaps a better starting point for the discussion of science and scientific method in journalism would be this book. How many of you know of this book? Yeah, right, okay. So this is, it's got this classic place in the history of data journalism. Philip Meyer wasn't the first person to use statistical techniques in journalism, not by centuries, but he was the first to really articulate what it was that we were doing when we do this. And notice the subtitle here, A Reporter's Introduction to Social Science Methods. So he conceived of a scientific journalism or a data-driven journalism as essentially a social science. And in fact, he was thinking of scientific methods not just in the production of stories, but in the analysis of their effect on the public. So if you read the introduction to this book, he's quite specific and talks at some length about the idea that we should not only try to produce knowledge scientifically, but we should try to disseminate that knowledge scientifically. So he was one of the first to talk about maybe journalists should understand how public opinion is shaped in scientific ways. So right there he says, the entire process of mass communication. The other thing I really like about this book is the way it talks about the interdisciplinary nature of science-based journalism. The green eye shade and the chi-square factions. But this is true today. It's an extremely interdisciplinary thing we're doing when we try to do journalism in science. I teach an interdisciplinary program. And it has to be, right? Because we are interested in something other than the production of knowledge, and this is a point which I'll return to. So I want to start off our discussion with arguably an example of journalists doing science, a modern example. This is a story that I was involved with in 2014 and 2015 when I was working for ProPublica. I spent nearly a year on this story, all told. And even then, I was just one of many people working on this. This is a story about health. This is a story called a project called Surgeon Scorecard. How many of you are familiar with this project? Okay, one or two. Okay, well, you're about to get intimately familiar with it. And basically, this project came about because preventable medical error, that is not things that a doctor couldn't do anything about, but mistakes in medicine, is actually the third leading cause of death in the United States, or is estimated to be. It's actually quite difficult to get these numbers. But we've known that this is a problem for at least several decades. There was a major study in 1999 which showed that this was the case. And one of the fixes that has been recommended consistently since then has been greater transparency in medical outcomes. So patient safety groups, medical researchers, all sorts of people have said for 2 decades, well, part of the problem is that we have no information about the quality of our medical professionals. So for example, there is no published information about a surgeon's outcomes. And yet, just sort of anecdotally or culturally, most doctors will tell you that they know that there are bad surgeons practicing. They will do things like try to prevent their patients from seeing certain colleagues. So ProPublica decided to take this issue on and produce the first ever public information on surgeon-level outcomes. Now, this was only possible because other news organizations had fought to make the data available. So this is another way in which the role of a journalist differs from the role of a scientist. A number of organizations went to court, most notably the Wall Street Journal. The journal had done a number of stories a few years prior on fraud in Medicare billing. So Medicare is the government-run healthcare for senior citizens in the United States. Something like, it's actually quite large, something like 2/3 of all of the medicine in the US is actually done through Medicare, which is surprising for a country with privatized healthcare, except that older people need more healthcare. That's how that happens. And there have been for many years summary statistics available, so you can do some types of analysis. But not the sorts of analysis that the Wall Street Journal wanted to do. And in fact, there was a 1979 court ruling that restricted access to this information. And the journal went to court, fought in court for almost 5 years and had this overturned. So suddenly, this is 2014, it was possible to get patient-level administrative data as a news organization. Now, it's not just something you download. There was, ProPublica entered into basically a contract with the government, which governed most specifically privacy, right? It had very strict conditions over how this data could be used, how it could be disclosed, and it had restrictions such as you couldn't report anything in an aggregate smaller than 20 patients, right? They were worried about de-anonymization. So if if you talked about a surgeon who had only operated on 5 patients and had 3 complications, it wouldn't be very hard to then, for example, look through news databases and figure out how those people are. So it was actually a rather complicated contract. But after this court battle, they were entitled to the information. And this is what the result looked like. So what this ended up being is a series of stories on sort of the general issues, and then a database where you could look up the hospital or the surgeon, and it would tell you their performance in terms of complications. So the basic metric is readmissions within 30 days for something related to the initial surgery. And so this is what this looks like. Let's see, we're looking at the outcome for a particular hospital here. So this is a hospital page. You can see for a particular procedure, you can see the number of times it was performed, and each one of these bars is actually a particular surgeon. Sorry, we've cut off the surgeon names here in this screenshot. But what you're looking at here is a 95% confidence interval on what we called the adjusted complication rate. And this is where the science starts coming into this. We didn't publish the raw rate of complications for a variety of reasons. One of which is that the different surgeons may have a different mix of patients. Some of them may be coming to the surgeon already sick, so we had to adjust for various health factors. Another is that we are sort of estimating the long-run complication rate for this surgeon. And to do that well, you have to incorporate an effect known as shrinkage, and I'll show you what that looks like in a second. Basically, you sort of end up moving everybody towards the mean to account for statistical noise. So in more detail, here's what we did. So first of all, we looked at 8 different surgical procedures. Of course, the data covers everything that's done at these hospitals, but we wanted elective surgeries performed on healthy patients. So no emergency room visits, no diagnoses with already complicated cases. We looked at healthy patients undergoing routine surgery for procedures where we had enough volume to get statistically meaningful results. So that leaves us with 2 million operations out of, I think our original database had 70 million procedures. Right? So first we take this little subset. And then we look at complications that are related, plausibly related to those surgeries. Right? So if they got a knee replacement and they come back with an infected knee, then we say, okay, that's probably something to do with the surgery. We consulted with doctors, surgeons, to identify these, and we actually went through the ICD-9 codes, which are the codes used to classify diseases and procedures for billing purposes, right? You sort of can't render a service as a hospital without giving it one of these codes. And for each of these 8 elective surgeries, we came up with a list of complication codes that were plausibly related to that surgery. And then we look at people who had the surgery and were readmitted with one of those codes within 30 days. And we got these counts. So you can see we're sort of in the thousands for each of these types of complications. And then we do a regression. We do a big multi-level regression. What we're looking at here is Each of these columns is a separate model for each of these procedures. That's why we have these 8 columns across the top. And we're looking at various factors in the regression, such as their age and sex, the health score, which was this model we developed to try to score their pre-existing conditions. So we filter out anything that's serious, right? We're only counting basically healthy people. But we look at things like, did they have, a prior history of diabetes, right? That sort of stuff. And actually used a model for sort of overall health level that we took from other medical literature, which we had to do, but you can see that it has almost no effect on the model, right? No one would have been able to take our results seriously if we had not adjusted for health, but it turns out that that adjustment has almost no effect. And then we have random effects at both the hospital and surgeon level, right? So what we're looking at here is the standard deviation of the surgeon level and hospital level coefficients. Now, the reason we do this model is the question we ended up asking is we are interested in what would be the performance of this surgeon as if they were at an average hospital, because there's a whole bunch of other literature showing that the hospital that they are at, different hospitals have different surgical outcomes. That can be because of, for example, the protocols that the hospital follows around cleanliness or any aspect of medical care. So that's why we have this multi-level model. We're trying to separate out the effects of surgeons and hospitals. And ProPublica didn't design this model alone. We consulted with a biostatistician at Harvard, right? So we worked with scientists to design this model, and then we took all of this data and built all these models and reported the results. Here's a sort of visualization of what's happening here. I spent many months staring at plots like this one, and I'll try to explain what's going on here. So the x-axis is just surgeons sorted by their adjusted rate. So the adjusted complication rate, the ACR, that's the thing we actually report to the public. And you can see that, it's mostly in this very narrow band, but then there are some outliers of very high and very low rates. So that's this central band here, right? That's the sort of modeled rate for this surgeon. These dots are the unadjusted rate. So those are the actual number of complications as defined by 30-day readmissions. The reason they end up in layers here is because when you get to very high complication rates, you start getting to small integer fractions, right? So you get to 3 out of 10 patients or something. What you will immediately see is that the dots scatter very much above and very much below the adjusted rates. So that's shrinkage. And shrinkage is a statistical effect you'll get in any type of regression or estimation, right? You'll get it in logistic regression as we do here. You'll get it in Bayesian approaches. What that is the model accounting for the fact that there's noise in the observations. So, for example, even if we see a surgeon who has no complications, they did 70 surgeries and none of them got readmitted for an infection, we don't give them a 0 score, or the model doesn't give them a 0 score, because given the mean of all of the other surgeons' complication rates, it's very unlikely that they're actually a perfect surgeon. It's much more likely that we just haven't observed a complication yet. And vice versa, right? When we start to get up here, where you get 5, 6, 7% complication rate, it's more likely that they got unlucky in some way. Or if you we're viewing only 100 or 200 procedures from a conceptually infinite random sample, and sometimes you see a lot of complications in that sample and sometimes you don't. So the shrinkage, aside from sort of falling out of the statistics, is actually, in many ways, being as fair as we can to the doctors. We actually compress the range of numbers that we report. And then these dashed lines are sort of, they're thresholds based on the slope of the curve. We try to set them where the sort of knee of the curve is. And we just call those sort of arbitrarily high and low rates, just to give some sort of benchmark. You can think of them as percentiles, right? So that you are perhaps like the lower and upper quartile. There are various views of the data. This is a different view. What this is now we are looking at, rather than looking at the rates for different surgeons, we're looking at all of the surgeons at a hospital for different procedures. And so each of these tick marks is one surgeon's adjusted rate. And what we do is we give a little warning sign if there's a surgeon who is in the red here, right? So this surgeon has a unusually high rate, so that you can think of that as in the upper quartile. So this is still online. You can go look this up. It was based on 5 years of Medicare data, so 2010 to 2015. You know, I was on it for about a year. All told, the main reporters on this, this is largely the work of Olga Pierce and Marshall Allen, and they took over 2 years, start to finish, to do this work. So, anyone want to guess what the reception was like? Yeah.
I would say that people say that you're changing the numbers incorrectly because you're doing reducing rates and increasing.
Yeah, that was one brand of criticism. You know, if I have 0 complications, why is my adjusted rate 1.5? Yeah. It was controversial. This really opened up a debate in the medical community. So you had this type of response, which is just, you know, quite negative. Although that's actually wrong. We didn't have exclusive access. We fought a court case so that anybody could have access. The arguments against it took various forms. There were a number of sort of technical arguments. You know, you've done your statistics wrong. The fact that your factors on the health adjustment are nearly 0 mean that your health adjustment isn't working. The confidence intervals are so wide that they don't give you any information. So that was a version of this here, right? So you can see that, you know, the 95% spans low and medium, right? And this one spans low, medium, and high. So they argued, well, there's no actual information there. It's not statistically significant. That one, so some of these I think people are just wrong. So for example, I don't think statistical significance is an issue here, because statistical significance is designed to, that 95% threshold is designed to prevent you from making a type 1 error, a false positive. But if, from the point of view of a patient, you're willing to have some false positives, what you want to avoid is the false negatives, right? It's okay if you think some doctors are bad when they're actually good. It's less okay if you think some doctors are good when they're actually bad. So some of these criticisms, I think, are just technical misunderstandings. More serious criticisms were things like, well, we know administrative data doesn't really capture the outcomes we're interested in. So for example, one of the procedures is a prostatectomy. And you know, we will capture if they come back in with an infection, but not if they have erectile dysfunction, which is quite common after prostate removal. So undoubtedly, yes, we don't have the data that we would like to have to assess the quality of surgical outcomes. And yet, I would still say that we did something valuable. So here's, I think, the best article sort of summarizing the criticisms of this project. And high up in the article, they say, ProPublica has thus migrated from the realm of data journalism to scientific analysis. I mean, yes, that's absolutely right. And you know, journalists are not scientists, but if no one else is doing science that has a public interest component, sometimes we're going to end up doing it because there's no option. But of course, the idea that journalists could or should be doing science is itself controversial. That aside, I think this is the main problem, that we don't actually have the data that we need. We're using administrative data and not medical data. And this is my favorite piece of criticism. With confidence intervals like these, who needs enemies? Indeed, we wanted the confidence intervals narrower as well, but this is the information we have. This article, however, also acknowledged the positive things that have come out of this. We have kickstarted a conversation that languished for 20 years. And in those 20 years, if you believe the estimate of the number of people dying from preventable medical error, 4 million people have died, right? That's a lot of people. The sort of more, I think, forward-looking doctors said things like this, right? This establishes a new standard for us to improve on. And part of the scandal here is that the medical establishment could be doing better and is not. So for example, there are various quality improvement programs, but most hospitals don't participate in them. So independent of whether the science was as good as we wanted it to be or not, we certainly kickstarted an effort to produce better measures of outcome. And so I think this was a very valuable thing to do, even if we couldn't get the robustness of the results that we wanted. So let's say for the moment that we accept the criticism that this was scientifically flawed, and that, you know, really we should have done, you know, a study with access to patient charts and, you know, taken another 5 years at it and got it peer reviewed and all of the sort of standards scientific process, right? Would that have been a better choice? I want to try to come at this from another angle. This is a paper. It's a real paper in a peer-reviewed journal. And it reports on an experiment showing that adding unsweetened chocolate to your diet, in addition to a low-carbohydrate diet, will help you lose weight. So this is was a real study. They really recruited a bunch of volunteers. It was actually done in Germany. It was published in a real peer-reviewed journal. It's statistically significant in all the right way. Everything checks out. And after this was published, the authors sent press releases to the media, and the media covered it, and it looked like this. So if you think that journalists shouldn't be doing science, then presumably you think that this is a better approach, right? They should cover other people's peer-reviewed, statistically validated publications. In fact, the whole thing was a fraud. But the way it was a fraud was very interesting, I think. So Johannes Bohannon, who's actually better known as John Bohannon, and does have a PhD, but it's not in medicine, put this whole thing together as part of his ongoing coverage and experimentation of scientific publishing. So chocolate does not help you lose weight. Can anyone guess how he got this result? P-hacking. Okay, so that's exactly right. The trick here was actually that when they started the study, they monitored 20 different variables. So they had blood pressure, they had cholesterol level, they had, I think they had like VO2 max, like oxygen consumption, that sort of stuff. And they just picked the variable that you know, had the most positive result. So they followed all of the right process and sort of exploited loopholes in our standard methodology. The other thing they exploited, John had discovered from previous research, about half of the journals that say they're peer-reviewed actually don't do any review. And we know this because he submitted a nonsense article and you know, tracked the 1,000 or so journals that said they were peer-reviewed and published it without actually reading it. So where does that leave us, right? It seems like even if you follow all the rules, you can get a completely ridiculous result. So I wanna jump a little wider here and talk about the dream that there will be some method that will give us truth. And this is a very old idea. There's a particularly good expression of this idea by a German who you may have heard of. And actually this is part of a longer piece which I really recommend you read. Leibniz was trying to create a language for thought, and he thought that if you used this language, truth would naturally follow. And you know, it's easy to see how if you've just invented calculus, this might seem plausible, but this doesn't work. It hasn't ever worked. And I want to say a little bit about why and what that means for journalism. And over, we keep sort of hearing that there are these magic bullets or gold standards for, you know, how you decide whether something is true, right? There are methods that will get us to truth. And these are all good methods, right? So remember I said at the beginning, my advice is journalists should use scientific method, which I agree, right? What I'm getting into now is the asterisks, right? So if you want an extremely good criticism of RCTs, you should look at the work of Angus Deaton. And he has amazing criticisms such as, you know, unbiased, statistically unbiased results is a nice property, but it doesn't actually get you much on in any particular case because you're not actually going to balance the arms. You're going to have some fluctuation that you can't track. Even if you have an RCT showing a positive result, you're going to have to make some argument that the study will generalize to the cases where you want to apply it. He sort of has this long list of arguments about why just doing an RCT isn't going to get you truth necessarily. Or Bayesian analysis, right? In principle, computing posterior probabilities just solves the problem of what to believe. But as soon as you start trying to apply this to problems that don't look like statistical estimation, you run into all of these crazy problems, right? You know, if the former controller for a city has a secret meeting with you and tells you, oh yeah, the mayor is definitely corrupt, you know, what's your prior probability on the mayor being corrupt, and how much should that information shift your belief, right? Like you can't actually use this method in real cases. And then there's this sort of other even deeper problem that in order to compute posterior probabilities, you have to be able to list the events as distinct hypotheses, right? So for example, there are statistical analyses that you can do to try to guess whether there has been election fraud. And this has been applied to Russian elections to look for unusual statistical patterns. But there are so many ways to fake an election. You have to be able to think of all of them ahead of time if you're going to use statistical methods to assess their probability. So this doesn't work either as a general method. And in fact, I claim there is not a general method for truth finding. And not only is there not a general method, but the recent history of science suggests that there is mounting evidence that we're never going to find a general method. So this comes in different categories, right? So there are sort of mathematical results like the incompleteness theorem and Turing's work on uncomputable numbers that suggest there are just, in a formal sense, there are things we're never going to get to. More interesting, I think, are the empirical problems, right? So when you look at what scientists actually do, it doesn't look anything like the scientific methods in textbooks, right? That's not how, when you get descriptive instead of prescriptive, you find that that's not how science actually works. And Kuhn really upset a lot of people in the 60s when he said this. You're probably all familiar with the replication crisis, which is shockingly recent, right? We could have discovered that any time in the last 50 years, but we didn't. I also, as a computer scientist, point to the failure of the symbolic AI paradigm, right? We used to think that we would get artificial intelligence by manipulating statements in formal logic, but we don't. It didn't work. And all of the progress in AI technology in the past 20 years has been statistical. So I think when you collect these types of evidence, they are evidence against the idea that there is going to be a single method that's going to give us truth, which means that you're not going to be able to hold journalism to some single standard, right? That's not how this works. And here I'm going to quote a rather radical philosopher who I think is very misunderstood, right? So he's remembered for this anything goes. But if you read him and you read his comments later, he doesn't mean, oh, you can do anything you want. What he means is that scientists are very creative, right? The search for truth presses people into inventing all kinds of methods, right? And there is no single method in practice. So I read this as optimistic instead of pessimistic. It says there's many ways that we can find truth. Now the softer sciences have come to grips with this a lot better than the quantitative fields. There's this idea of triangulation in the social scientists, and it says that, you know, what you want is not one method, but a lot of methods that point you in the same direction. And this starts to be directly relevant to journalism, right? You're looking for multiple lines of evidence that are telling you the same story. And here's an example from Phil Meyer. Here is a Pulitzer Prize-winning story on what is known in the United States as redlining. That is discrimination for home lending on the basis of race. And so you can show that this still occurs even today with statistical analyses. But if you want to do a good piece of journalism on this, you don't just do a statistical analysis, you go out and you talk to people, right? You find individual stories and individual case studies, not just because you want to bring the human element into the story, which is always important, but because you want to ensure that what you're seeing in the data matches what you're seeing on the street. And if you look through the philosophy of science, you can find this other view. Rather than this sort of Leibniz view that there is a method that will give you truth, you can find this other view that you need to be very diverse in your methods and your reasoning. And here's Peirce, who arguably invented the randomized controlled trial, saying much the same thing in the 19th century, right? So I love this quote. Its reasoning should not form a chain, but a cable whose fibers may be ever so slender, provided they're sufficiently numerous and intimately connected. So I think this should be our model for truth, right? We want to come at it from a lot of different directions. Okay, I'm going to switch topics only slightly to something that I think is very connected, even though it may seem very different. Some of you may know I've done a bunch of work trying to apply artificial intelligence techniques to investigative journalism, and one of the central problems there turns out to be defining what is a story. I want the AI to find stories. Okay, well, what's a story? And this is sort of the promise. Now, this is sort of an extreme version, or this is very much hype around artificial intelligence. And this quote that a machine will win a Pulitzer is from someone who is selling software that writes stories, so maybe we shouldn't believe him. But machines are definitely writing journalism today. And when you read even academic work about the potential of AI in investigative journalism, it's always this idea of finding stories, right? Going through the data and finding stories. So people have done this. What I'm going to call the simple cases when you know what you're looking for. So, for example, the Atlanta Journal-Constitution went through over 100,000 doctor disciplinary reports to look for cases of sexual abuse where the doctor was permitted to practice afterwards. And they did this using a supervised learning model where they trained it to pick out the documents that likely contained such a report. Here's another case. This is BuzzFeed finding surveillance planes that are secretly owned by the government. And they did this looking for these circling flight paths, which is how surveillance planes fly. What if you don't know what you're looking for? Well, if you have to sort of engineer it from first principles, you end up sort of inventing thresholds for newsworthiness, right? Lots and lots of things happen in the world every day. Which ones of them are news? In this case, for the Associated Press automated business stories, right, the automated earnings reports, they had to manually program, okay, by what percentage do they have to miss earnings expectations before it counts as a story? Or, you know, how many violent crimes in a week counts as newsworthy? How big does the earthquake have to be before we issue an alert? You have to sort of come up with these thresholds. And this is because, as I like to tell my students, stories don't exist in nature. A story is a human-created artifact, right? Stuff is happening, but we have to pick certain events and say, this is newsworthy. And even professional journalists will have a hard time articulating what newsworthy is. So we shouldn't expect that this is easy for a computer to do either. Again, this is sort of converging on this idea that there isn't going to be a single method that will tell us what truth is, or in this case, what a story is. Now, one approach you can take to solving this problem is you can try to make the computers mimic the humans. So the Reuters tracer system, which they use to find breaking news in from tweets, right? So they monitor a huge fraction of all of the tweets in the world, and they try to alert their journalists when something newsworthy happens. And to do this, what they did is they took the top stories from Google News for a month and used that as training data for their system, right? So they're just trying to replicate what journalists already do. And this works. The problem is what journalists already do may not be what we want to do. So this was a summary of, this was from a piece on crime coverage I wrote a few years ago. Most homicides do not make the news. In smaller places, perhaps the majority do. But overall, only the most sensationalist ones, right? If young victims, famous people, women, sex crimes, especially violent crimes, this sorts of things. So just doing what journalists already do is just going to replicate biases invisibly. What I'm leading up to in all of this discussion of the difficulty of finding news is, I think for a room full of communication scholars, an obvious point, which is that there is a normative component to the practice of journalism, right? We have to say something about what should be news or what the world should look like. And this is a quote from a paper by Meredith Broussard, and I think really distills one approach to this problem. When there's a difference between what is and what ought to be, that's a story. So to some extent, scientific method can inform us about how to determine what is, right? We have standards of data analysis. We have, we had to adjust for the health of the incoming patients to get any sort of plausibly accurate idea of what doctors are doing. But implicit in all of that work was that we shouldn't have these outlier doctors who have very high complication rates, right? If you're that bad at surgery, maybe something is wrong. So we're not going to be able to scientifically define what a news story is. We're not going to be able to derive from first principles what it is that an AI system should be looking for in data. We have to inject something else in there. And this is the sort of language I've come up with to talk about this problem. When is a fact pattern a story? Well, it depends on the context. It depends on our politics. It depends on our norms. Things which weren't a story 10 years ago are a story now. I mean, look at the Me Too movement, right? The norm shifted, and a whole set of fact patterns that were not news are now news. Okay, the last thing I want to talk about is transparency. Because if there is no one method for finding truth, and there is no one method for deciding what counts as a story, then as we use computers more and more for both of these things, we're going to have to communicate the choices that we have made. So the good news is that many news organizations are much better at revealing the methods that they use when they use computers to do journalism. The bad news is they often do that by checking their code into GitHub. And don't get me wrong, this is a big improvement over where we were even 10 years ago. The problem is that the people who might want to know what the reporter did are, by and large, not able to read code, right? So I suppose this is transparency, but it's not really in a form that allows the audiences or the eventual end users, the people who the journalism is meant to serve, to understand what we're doing. As it turns out that even if you publish the code and data, you don't necessarily get the same result. I think this is unsurprising if you're a software engineer, and perhaps shocking if you're not. But this is a lovely little paper where two researchers tried to replicate a bunch of economics data analyses with the original code and data, with the assistance of the authors. And they could only make half of them work. So that tells us that even publishing the original code and data is not going to be enough. We're going to have to start to look at things like containerization, or sort of all of the software engineering practice that we have to try to solve this problem. Which leads me to the last thing that I'm going to talk about today, which is my own attempt to try to solve some of these problems, which is the tool I've been working on with my colleagues Pierre Conti and Adam Hooper, called Workbench. So there's going to be a workshop on this tool at 4:30 today, but I'll just go very briefly over what it is. It is a system for procedural, reproducible data analysis without coding. So here's the basic idea, is that everything, it looks kind of like a spreadsheet. Here I'm showing a chart, but normally you'd see a grid of numbers. And everything you do is recorded as a step. So in this case, I'm doing a grouping operation. You might know it as a pivot table. Just to try to, I'm starting with crime reports in San Francisco, and I'm just grouping them by the city district. Yeah.
No, go on. Just 5 minutes and we have
Yep.
some time for questions.
The idea here is that not only can audiences see what you did, or can a non-technical editor review the steps that were taken, but you have a way to share process. So I can do an analysis of a city budget in a certain way, and then because it's in this format and it's an online document, I can give it to someone else who can duplicate it and then modify it or reuse the process. So it's a way to document and share method. And because data analysis, even in this form, is pretty complicated, it is also a training tool. So it includes a built-in data journalism course to teach people the fundamentals of how to work with data. And the idea is that the system that you use for doing the work should also teach you how to do the work, right? So it shouldn't be like, you know, you have to go off and take a course or study a stack of books or whatever. If you are interested enough to look at what someone did, in other words, to sort of step through this type of process, you should be able at any point to say, oh, well, help me make my own. Teach me what this group process is. Or even train me from scratch to work with data. Okay, so I'm going to try to bring this all together and talk about the goals of science and of data journalism, because I think all of these differences, all of these things I've talked about that are not quite like science stem from differences in goals. So arguably, we do science to produce knowledge, right? That's what we're trying to get done. And that's what science is judged as, right? But journalism has other goals, right? We not only need to produce the knowledge, we need to tell people about it, and then we need to have influence in society. If journalism is to have any value in a democracy, it has to change something, right? So persuasion and influence are core parts of what we do. And going back to the ProPublica story, you know, I think we produced knowledge. I think we produced very imperfect knowledge. And I think that many of the criticisms of Surgeon Scorecard are right. I think it's not the measure of surgical quality that we want. But I think we did very well on the other axes. I think we opened up a debate and influenced the direction of medical research. And so even though you can make methodological arguments about what we did, I still think that it was a valuable thing to do. All right, so here's my whole talk in one slide. Yes, you should use the scientific method, but there isn't a method, so you're going to have to tell people what you did. All right, thank you very much, and we have a few minutes for questions.
Yeah. Thank you a lot for this fascinating overview. Many topics raised, and he will be here for discussions the whole day and tomorrow. So anybody who has questions more deeply, plug one or two questions. So if there is some immediate questions somebody wants to ask. Björn?
Thank you for the talk. I was impressed by your numbers on the success of replication of scientific studies. We know this if you are a programmer yourself, you see that code doesn't run through the second time, but that's mainly by upgrades of the versions. So what other reasons did they find apart from that versioning issue?
So they found just some plain errors. So like the data and the code, well, I guess that might be a versioning issue as well. But the data and the code didn't match. And then they found just straight bugs as well sometimes. It's a really fascinating paper. There's just lots of reasons why this doesn't work the way it should.
Yes, I have just a comment and a question concerning the chocolate study, because, well, there was not only John Bohannon, but also two other journalists from Germany, from the ZDF. And I think one goal was also to check not only the media, but also the system of scientific peer review, so science itself, if it works or not. And that's my question, that leads to my question. So do you think journalists should also check a little bit if scientists do a proper work or not? So is it another role that data and science journalists should have?
Interesting. I think my instinct is to say yes. I think journalism's role as journalism has long had a role as an independent check on power, and to the degree that scientists or scientific institutions are powerful, then they are certainly subject to journalistic scrutiny.
I have one question concerning this surgeon scorecard. So what would have happened if the scientists you were kind of cooperating with would have convinced you to not run the story? Because from the point of what information and knowledge you can gain, maybe not in the system and the data you have, you cannot just see really the effect. I mean, you argued that it's good that the public knows, of course, that there are differences we can't really measure, but they may be important, people may die. So what would have happened if you have a scientist saying, well, please don't do this, this is not the way it should be in the public domain?
Very interesting question. So I can talk about what I think would have happened, and I can talk about what I think should happen. I think what would have happened is we would have found another scientist. Because, I mean, you know, investigative journalism has sort of the opposite failure mode of science, right? In science, you get the file drawer effect where things aren't published. In investigative journalism, you got to publish something because it's very expensive, right? You can't do nothing for 2 years. So the tendency is to err on the side of publishing something. Perhaps a better approach, you know, if you really have experts saying, you know, this isn't a story, this isn't going to work, maybe you shouldn't publish. On the other hand, it might also, maybe a sort of way to split the difference would be to publish a story that said, you know, we looked at this and determined that we couldn't figure out the right answer. Now, that's a very unsatisfying story, but there is precedent in journalism. So, for example, if you're trying to investigate something and the data you need to answer the question is not available, you can run a story saying, for example, you know, we tried to evaluate the internal disciplinary system for the police, but they don't make the records public, so nobody knows if that's working properly.
Okay. If there is no further question, I would close this session, but I would let you know, as he said, at 4:30, he will present this workbench approach a little bit more in a workshop fashion, so anybody who's interested can join this session. So thank you again. It was very stimulating, and lots of thoughts going in my mind. And well, now we have to change gears for the next session. Thank you.